It is day 2 in Algebra 2, and yesterday we talked about systems of equations. So today, or do now, I've given you 3 systems to solve. So number 1, I'll start by guiding us through it, just to remind us how we do it. And I'm going to ask for your guys' help on some of these too. I love it when you guys participate. So number 1, I've got 2 systems or 2 equations here. My first equation is 6x plus 7y equals 51. My second equation says y equals 3. My goal is to figure out what number can I plug in or replace x with, and what number can I replace y with to make these equations true. So something is already solved for. This is going to make our lives easy. What's already solved for here? Y. Y is equal to 3. Let me pause real quick. All right, so I already know what y is. Y was given to us, which is nice. One less thing to do. So since I know what y is, I know y is 3, how can I use that to help me solve for x?
23, y 771.
Yes, let's plug this value in and replace it. You cannot solve an equation with 2 different variables. We have an x and a y. So if I can replace y with a number that's not a variable, well, suddenly when I rewrite my problem, this is what will happen. Let me get another color here. I'm just going to rewrite this equation. 6x plus 7. I'm not going to write y. Instead, we're going to use 3 equals 51. And now we notice we only have one variable. That y is no longer there. Now we have a 3 instead. So I've substituted y. I put 3 in. Now that I have this all plugged in, what would I do from here? Yes, now we're going to distribute 7 times 3. And remember, distributing is just multiplying. It's just a fancy word. So 7 times 3, what does that give us? 21. And I'm going to cross out my 7 times 3 so that I don't accidentally bring it down. Let's bring everything else down. 6x plus 21 equals 51. Where would I go from here?
21 on both sides.
Yes, minus 21 on both sides. Okay, those 21s cancel out. So what comes down?
6x.
Good. 6x equals 51 minus 21 is 30. And I've got one more step to go. Divide. Good, we'll divide by 6. And my 6's cancel, and I'm going to get an answer of x equals 5. 30 divided by 6 is 5. Good. So x is 5. Y is 3. They already gave us that. So how should I write my answer for this whole system? You guys remember how I told you to do it yesterday? A coordinate. A coordinate. Yes. Remember, if we have an x and a y, we're referencing a graph. We're going to have coordinates. Yes. X always comes first. X is 5. Then y was 3. So our answer is 5, 3 in a coordinate, just like this. How many of you got that right?
Yeah, for the most part, so very.
I didn't do that.
Did you forget to divide that 6 on the 30? That's all right. That's good. That's good. Sounds like we're on the right track, you guys. That's awesome. Okay. Now, before we go on to another one, do we have any questions about any part of this on number 1? Is there any step that didn't quite make sense?
Do you always want us to put a coordinate whenever we do these?
Yes.
Okay.
Very good question. Do I always want you to write your answer as a coordinate? Yes. Always, always. So remember, the coordinate is just putting the answers in parentheses, X first, then Y. So yes, thank you for asking that. Okay, so that was number 1. Let's look at number 2. And before we jump ahead and solve it exactly like we did for number 1, there is something different about number 2.
It's the X value instead of Y.
Yes, I tricked a few of you. I tricked a few of you. So in the first problem, we had Y equals 3. So we were able to plug in 3 for Y. In the second problem, I'm telling you that X equals 7. So you're not going to put 7 in the Y spot because this is not Y, this is X. So we need to be careful what we're plugging into and make sure that it matches the variable. So first I'm going to circle this X equals 7 because X is solved for. That's really nice. And I like to, just like I did on number 1, I circled my Y because that's what I'm plugging in. I'm going to circle my X because that's what I'm plugging in. Oh, I think that, hang on, let me pause this. I think someone's at the door. Okay, so now that I have my my X identified, I know X is 7. What am I going to write at the next step?
7 minus 4y equals 9.
Yes, instead of X minus 4y, I know X is 7. We're going to write 7 minus 4y equals negative 17. And I just put parentheses there to show that I'm plugging in 7 for X. Do not include X in this problem. We've replaced X with that 7 because we know that X is 7. So now that I have my 7 plugged in for X, where do I go from here?
Minus 7 for both sides. 17.
Yes, we have a positive 7 right here. And I'm trying to get Y by itself, okay? So I need to get rid of this positive 7. Even though it doesn't say plus 7, it doesn't say that it's a negative 7. It's a positive 7. So to get rid of it, we need to subtract 7. And we need to do that to both sides. I'm going to draw a line through my equal sign to keep myself organized. So minus 7 over here, minus 7 over there. What happens with my 7s? They cancel out. And so what's left to bring down on this side?
4y equals negative 24.
Good. Negative 4y. Bring down my equal sign. And then be very careful. You have 2 negatives. On your calculators, I'll review this again just to make sure we remember. If you ever forget how to type in a negative number, on the bottom of your calculator, near the bottom, you have in parentheses a negative symbol. Push that first and then type the number. So I have negative 17 minus 7. Enter. Negative 24. Rely on the calculators because if you type it right, you're not going to get it wrong. So I've got negative 4y equals negative 24. And we're almost there. I almost have y by itself. What's my last step?
Both sides of 4.
Yes.
Negative.
Yes, thank you for correcting yourself. Negative 4 will divide by negative 4 on both sides. I heard somebody say, wait, what? Who's confused? Tell me. Is anybody not sure why we just divided by negative 4? Or did we figure it out?
Did you say put in your calculator negative 17 minus? Never mind, I did it backwards. Don't mind me.
The negative 17 minus 7.
Yeah, I was putting negative 7.
Oh, you're okay. Okay, so again, if you don't have your positive and negative rules memorized, rely on your calculator. It won't do you wrong. we've got negative 24 divided by negative 4. Two negatives make a positive. But if you forgot that, just type it in. Negative 24 divided by negative 4. Enter. Positive 6. So you should have gotten y equals 6.
Oh, really? Yeah, I can do that.
You got it? All right. So I solved for y. How do I finish out this problem?
Just two variables down.
Yes, I'm going to write both my variables as a coordinate. What number comes first? Yes, 7. I almost corrected you guys. I'm wrong. 7 is x. Be careful. I almost wrote 6 first. 7 is y, or 7 is x. 6 is y. That is our answer. Very nice. All right. I'll give us a minute to kind of let that soak in. And before we go to number 3, please don't be afraid to tell me if you have questions.
Can you slide your page down?
This?
Yeah.
Or, okay, perfect. Yes. All right, and I'll just pause this for a minute while everybody writes. Okay, so number 3, we have another system where y equals 5 is my first equation. My second equation is 3x plus 4y equals negative 4. Would anybody like to tell me what they did first to start this problem? Yes, plug in your y. I know y is 5 already by itself. So I'm going to circle that. And in my second equation, I'm going to identify my y, which is right here. So we're going to plug in or replace y with 5. So I'm just going to rewrite that equation. 3x plus 4, not writing y, we're writing 5, equals negative 4. Okay, so I've plugged in my y value. What should happen next? Yes, multiply 4 times 5, which is 20. And then we'll bring everything down. 3x plus 20 equals negative 4. And again, if drawing a line through the equal sign is helpful to you, do it. It may keep you organized. Yes, now we're going to subtract 20. We're trying to get x by itself. So I need to get rid of 20 minus 20 on both sides. And let's see, my 20s will cancel. Bring down my 3x equals, what is negative 4 minus 20?
Negative 24.
Good, negative 24. Yes, divide by 3. Negative 8. Very good. Very good. We got x by itself equals negative 24 divided by 3. We already said it, but that is, in fact, negative 8. Okay. Did anybody get a different answer that feels comfortable maybe sharing what you did differently? Yes. What did you get?
I got 16, positive 16, and I realized that I didn't put the negative 20.
Ah, I see. So you added 20, right? Okay, so this is a really good thing to point out. If you accidentally did plus 20 on both sides, you would have gotten 3x equals 16.
That's exactly.
Right. And then you're not going to get the right answer. And that's okay. We recognize our mistakes. We improve from them. Why do I need to subtract 20 instead of adding 20 here?
Because it's already positive.
Yeah, this is already, it says 3x plus 20. If I add 20 to both sides, I'm going to now actually have 3x plus 40 equals 16. Now, you could do that, and you could still solve the problem from there and get it right, but it wouldn't be right if you said that adding 20 makes these cancel, because it doesn't. It doesn't. 20 is positive. So if we're trying to get rid of it, we need to do the opposite. That's a good catch. Good catch. Okay, so any other mistakes maybe that we noticed that might be helpful to talk about? Yes.
I ended up getting +8, but the way I did it, I added 4 to the 20, and then added +4 to the -4.
Okay.
So I ended up doing it like 3x divided by 3, cancel that out, and 24 divided by 3 is how I got the.
I know exactly what you did. I'm going to write down what you did, because I see this all the time, and you are not the only one that's done that. That's so common to see. So it sounds like what he's telling me is he had the 3x plus 20 equals -4. And you said you decided to add 4 to both sides?
Yeah.
Okay, so you added 4 to both sides. Let me get a different color, you can see better. Add 4, add 4. Now here's where drawing a line through the equal sign can be very helpful, because this is what happened. You did 20 plus 4 is 24, and then you brought down your 3x.
Yeah.
And then -4 plus 4, did you just say those cancel?
Yeah.
Okay. So do we see why this won't work? If this cancels, well, when we say something cancels, it's because it equals 0, right? Okay, so normally we can just cross it out if there's something else to bring down with it.
Right.
But there's nothing else over here, so we would need to write that 0. It sounds like you moved your equal sign.
Yeah.
Yeah. So what you did is you just were like, well, I don't know what's over here, so I'm just going to say there's the equal sign. But we can't do that. There's a line here. So then you divided by 3.
Yeah.
And you got x equals +8. Okay, so now you see what happened. You can't do that, because I'm serious, Diane, I'm glad you've been having me draw this line, because it can be so helpful. If this line is here, you'll see, well, my equal sign has to be here. I can't just put it in between 3x and 24, because there's a plus sign here. Good. Thank you for sharing that. I'm sure that's going to help somebody else in here too. Awesome.
Even though he came up with the correct answer.
Did he though? X is -8. He got positive.
No, you're right.
Oh, so he was very, very, very close.
Yeah.
Yes, but that little mistake, you're going to get the right number a lot of the time, but it will be the incorrect sign. Keeping your work organized is so important. It's those little details. Yes, Stacy.
Like write in Word form the steps of like that you get to solve these.
Solve these. Yes, absolutely.
Okay.
So, oh man, I hate when this happens. Come on. I know. Okay, there we go. So before I do that, let's finish this problem out, and then I'm gonna give you some steps. So I solved for x, I solved for y. What is my coordinate?
-8.
Good. -8 is my x, so it comes first. 5 is my y, so it comes second. X, y. Wonderful. Okay, so that little piece is going to bug me. Not take it down. A little better. Okay. So before we try that challenge problem, I'm going to pull out a little sticky note to the side. And if you are somebody that would find this helpful, feel free to write it. If not, this is optional, but it may be helpful. Let's write out in words the steps that we're taking to solve these problems. So for all three of these problems we just did, what is the first thing that we did?
Plug in your variables.
Yeah, we basically decided if there was an equation that was already solved for x or y, so like in number 2, I had x by itself equal to 7. Number 3, I had y by itself equal to 5. The first thing we did is we plugged in any values to get rid of variables. So I'm going to write for step 1, plug in x or y, depending on which one you're given, right, to the other equation. And that EQ is, I'm just abbreviating, I mean equation here. So once we've plugged in our x value or our y value, what normally happens next? So I'll look at number 3 here. I just plugged in my y. Now what? We end up multiplying a lot of the times next. So for number 3, we had 4y, which meant 4 times y, or 4 times 5. So, bless you. Number 2, we didn't multiply because why did I not multiply something in number 2? When I plugged in 7 for x. Because I have a positive 7. Looking at my original equations, there's no number.
There's nothing to distribute.
Right, there's no number in front of my x. So I know that there's just one x here. X is 7, so it's just 7. If this was 2x, I would need to do 2 times 7, right? So for step 2, let's see, how could I word that second step? I don't want to just say multiply because it's like multiply what? What could we write for step 2? After we plug in the number.
Multiply the variable and it has a number.
Yeah, okay, that's a good idea. So multiply any number that was attached to the variable. Does that make sense? Okay. So multiply. I'm going to write multiply / distribute because we kind of call that distributing too. Multiply / distribute if there is a number in front of the variable. So I'm going to write if there's a number in front of x or y. Okay. So there's step 2. I'll put this right here. So step 1, we plugged it in. Step 2, we did the multiplying. I did the 4 times 5 equals 20. What is the next thing that we do in this process? Yeah, you're either going to get x by itself or you're going to get y by itself, depending on what variable is there. So since we replaced y, we're solving for x. We plugged in y, we solved for x. In number 2, I plugged in x, so I solved for y. You're going to solve for the variable that you're left with. So if I put for step 3, finish solving the equation, does that make sense for step 3? Okay, maybe not.
I put get X and Y by itself.
Get x and y by itself. Okay, that sounds good. Let's do that. Okay, so once you've distributed or multiplied, now we get x or y by themselves. And I'll put solve the equation in parentheses. And so that step 3 was here. We subtracted 20 from both sides, and then we divided by 3. We got x by itself. And what's my last step? Write your answers in a coordinate. X first, then y. So put x, comma, y in a coordinate. Okay. So those are 4 good steps to follow whenever you're solving systems like this. I'll pause that for a second and leave that up if anybody's writing. Okay, so why are we getting -8 for number 3? Another little rule, whenever you are multiplying positives and negatives, this is a really good chart to keep in your notes, so I'm going to draw this out for you guys. If I multiply or divide 2 positive numbers, will my answer be positive or negative? Positive. If I multiply 2 negative numbers or divide, this works for multiplication or division, do I get a positive or a negative? You get a positive because the signs are the same. Positive, positive gives you positive. Negative and negative, they are negative, but the signs are the same. If the signs are the same, you get a positive answer. It's like they cancel each other out. If I have a positive and a negative, now I have different signs. It doesn't matter which number is bigger or smaller. I have different signs. Will I get a positive answer or a negative? Negative. What if I have a negative and a positive? You're going to get a negative answer again. So let me explain what I just wrote again. Yes, Stacy.
You remember in my last term review, I told you that one thing my old teacher said about that song? I don't remember. It was a multiply or divide. It's an easy thought. Same signs are positive, different signs are not.
Oh, yes, yes. I like that. Say that again for us.
Multiply or divide. It's an easy thought. Same signs are positive, different signs are not.
Same signs are positive, different signs are not. Same signs, 2 positives. These are the same sign. Our answer is positive. Same signs. Yes, the signs are negative, but the signs are the same. There's a negative number and another negative. They're the same, so it's positive. Different signs are not. Different signs again, not. Negative, negative. That's a good way to remember. Same signs positive, different signs negative. Gabe, does that answer your question?
Yeah, I
Okay.
got the rule.
Right. That's no problem. No problem. Yeah. Keep this on a sticky note somewhere. This is something that is very helpful. The other thing is if you ever forget or you lose the sticky note that you wrote this on, rely on your calculator. If you're typing in the negatives in your problem, you're going to get the right answer every time. And of course, if you ever forget how to type that in properly, you can always ask. I'm happy to help and remind. Okay. Does anybody still need to see this pink sticky note? Anybody still copying down the steps we talked about? Okay, I'm going to move that to the side. Is anybody still copying down positives and negatives chart here? Speak now. I'm going to move it. Okay, I'm going to go ahead and move that. Of course, ask if you need to see it again. And now we're going to look at the challenge problem. So I'm going to turn this page, if that's okay with everybody. Can I change this page? Okay. All right. So on my next page here, this is still kind of part of the do now. I'm going to write this problem that I gave you. And if you hadn't seen it yet, feel free to write it now. So this was an optional problem. I gave you two equations where the first equation says y equals x minus 3. We didn't do one like this yesterday. That's why it's a challenge. And then the second equation is 4x plus 2y equals 30. And we're doing the same thing. We're solving for x and we're solving for y. Did anybody attempt this problem? You attempted it? Does anybody think that, like, they feel confident they got it?
Yeah. I attempted it, but I don't think
Okay. Okay. So anybody that did attempt it, if you feel comfortable sharing, I'd be curious to know what you did first, what your first step was.
I took and wrote it down as 4x. I don't I'll see what I did wrong.
It's all right. It's all right.
And multiply the 4 times the 3.
Okay.
Yeah.
Gabe, did you? Go
I don't
ahead.
know if I got the right side for this one.
Okay.
Plug in the y minus 3, no, x minus 3, 2, so 2 parentheses x minus 3.
Yes. 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 Okay, if you didn't hear that, you just told me the correct thing. That's amazing. So in all the other problems, we had y equals a number or x equals a number. Now I have y equals x minus 3. What? Okay, well, guess what? I still do have y solved for. There's just a variable on the other side. I have y is equal to x minus 3. So I'm going to circle this a little bit differently before I tell you exactly what Gabe just told me. I'm going to circle all my things that are y. So here's a y. Here's a y. And guess what? Equal sign tells me that this is also y. Y is the same thing as x minus 3. So I'm going to circle all of this, x minus 3. Do we see that because it says y equal x minus 3, that this is technically y? So here's what we're going to do. I can't get the second equation, I can't get it to where it's 2 times a number, but I can get rid of the y and make it so that my problem only has x's in it. Because luckily the other half of this y equals, it says x minus 3. There's an x there. So whenever we rewrite the second equation, I'm going to write 4x plus 2. This is where I'm writing y. I don't want to write y because I'm trying to replace y with a number. I don't have a number either, but I do have this value here, x minus 3. So we're going to write that. You see what happened? 4x plus 2y. 4x plus 2 times x minus 3. There we go. And I need to copy the rest of the equation over. There's still equals 30. Okay, now before we move any further, is anybody completely lost about what I just did? Or do we feel okay?
Well, I understand,
Uh-huh.
but I put the -3 in the x place.
You put the -3 in the x place, like right here?
Mm-hmm.
Okay.
Subtracted 2 from that, put it on 1 side.
Okay, so were you maybe thinking that since there was a y and an x, maybe that this was telling me that x is -3? Okay, that makes perfect sense. So I can definitely see why you did that. She was telling me that she put -3 in for x. We can't do that because there's a y here. So I can only replace things that have that variable by itself. If I wanted to, I could rearrange my top equation. It would make things more complicated. And I could say x equals y plus 3, but I would need to make sure that I'm putting y plus 3 here instead of just -3. We won't get into all of that yet because that's going to confuse us. We're not there yet. But we're going to try it like this. Is anybody else got things that they want to address before we finish solving this? Okay. So we did step 1. I plugged in my y value for y into the other equation. Step 2 says we're going to multiply or distribute if there's a number in front of that x or y. Is there a number in front to distribute?
Yeah.
There sure is. There's a 2. So the difference in this problem is I'm not just doing 2 times one number. I've got an x and I have -3. We're going to distribute 2 times x and 2 times that -3, -3. So what happens here?
I did what Sylvia taught us and put the
Yes.
visible 1 in front of x and did 2 times 1.
You can absolutely do that. Okay, I want to point that out too. If having x by itself with no number in front of it feels confusing to multiply, something we can remember is that x by itself is the same thing as 1x. If you want to write a 1 in front of your x, you can do that. It works the same way. Yes.
To add to what you just said, if it was another question the same way, but it was x, y instead of x by itself,
Yeah.
would that still be the same?
Yes, it should be the same. And we'll run through so many more examples that'll hopefully make it all click together. We'll start to see patterns the more of these problems that we do. Okay, so I'm distributing. What is 2 times x? 2x. What's 2 times -3 or -3? -6 or -6. Okay, so I did those 2 little multiplication parts. I know myself, if I don't cross things out, I'm going to accidentally bring them down. So I'm going to cross that out so I know that I'm done with it. And I'm going to draw a line through my equal sign, keep myself organized. And what should I do next? Yes, bring down 4x. I've got plus 2x minus 6 equals 30. Good. Okay. Now we've got something different happening here. What do I need to do?
Like there.
Yes, add 4x and 2x. You've got some like pairs. Over here, before I start trying to solve or move things to other sides, I want to see, do I have any terms meaning numbers with or without variables? Like I have a 4x here, that's a term. I have 2x, that's a term. I have minus 6, that's a term. I have 30, that's a term. 4x and 2x both have the same variable. They have x's. So we can combine those, can't we? I'm going to circle them. And I'm going to say, we're going to put those together and we will get 4x plus 2x is 6x. And then we need to bring everything down. What comes down? Minus 6 equals 30. Good. Okay. What's happening now? Yeah, let's get rid of minus 6. We're going to add 6 on both sides. Hi, Jesse. So add 6 to both sides. Yes, we'll get 6x. I'm bringing that down. Equals 36. And I have one last step to go. Divide both sides by 6. Good. Okay, so my 6's cancel, and I get x equals what? 6. X equals 6. Very good. Okay, so I solved for x. I solved for x. Are we done now? Oh my gosh, we have to figure out why. This is where the challenge comes in, because normally, or at least what we're used to, we've got y equals just a number and we don't have to solve. Or we have x equals a number. We already know what that is. This time I have y equals x minus 3. I don't know what y is, do I? How can I figure out y? Stacy.
You just subtract 3 from the 6 because x equals 6.
Yes. Okay, so just like to solve for x, we had to plug in our y. You see that? We plugged in y, and then we found x. Can't we just take our x and plug that in to solve for y? So we know what x is. Now we know x equals 6. So y is by itself over here. Let's do this. Y equals, I'm going to rewrite that top equation without plugging anything. Y equals x minus 3. I know what x is. X is 6. So I'm going to rewrite that, but I'm going to replace x with 6. Y equals 6 minus 3. And what's my y value? Y equals 3. 6 minus 3 gives us 3. Do you see what we did there? So whenever you don't already have one variable solved for, that does add an extra step at the end where you will have to solve for that last variable by plugging in what you know. I'll draw an arrow to show that's what we did. Plug in x. So this whole problem went kind of in a circular motion. We plugged in the y value. We did some work. We solved for x. We plugged in the x value. We did some work. We solved for y. We're almost there. One last little thing. What's my coordinate?
6.
6 comes first. It's my x value. Then 3. That's my y value. Beautiful. Very, very, very nice. Okay. You guys don't even realize it, but you just did that first method I told you about this morning, substitution. You just did that. That's substitution. It's just a tiny bit more complicated than what we've been doing. So real quick, I do want to go ahead and check in with all of you. It is 10:13. Normally what I like to do is around anytime between 10 to 10:30. Usually after we spend some time on the do now, I like to give you like a 10-15 minute break to get up, stretch your legs, use the bathroom, get a drink, check in with me if you need to. And then we will come back after that break and get a little more into these systems, probably do some more practice on your own and together as a class. After we've done some practice, you will get your exit ticket at the end. So at this time, we are going to go on break for 15 minutes. Be back in here by 10:30. If any of you have questions for me, feel free to stay. If you are coming in for the first time today and I have not checked in with you yet, please come check in with me and we'll make sure that you know exactly what you're supposed to be doing and we're all on the same page. So take a break, be back at 10:30. I'll write that up here too. Okay, so we are back from our break and I just handed out, let me unfreeze my screen. I just handed out this worksheet that says substitution. Don't feel like you got to get started on it just yet because we're going to take a note or two first to give us a guide to what substitution is. That number 4 that we did together, this was like your sneak peek. And now we're going to actually jump into making sure that we understand what is substitution. How can we use it for any given problem? So go ahead and put that worksheet to the side and take out whatever you like to take your notes in. And I'm going to title a new page for us today. So, Algebra 2. Unit 1. It is day 2 today, so we're going to title this as our day 2 notes. And this is page 1. And it is Tuesday, October the 7th. So, for our notes today, I'm going to have you write another little title under day 2 notes that says equation forms. Equation forms. And we're going to talk about a few different sort of formats or layouts for how equations can be written and how we can use that knowledge to help us solve systems with this substitution that I'm about to teach you about. So first we have what is going to be written as capital A X plus capital B Y equals C. AX plus BY equals C. This is what we call a standard form equation. So if you notice on this worksheet or any of those do now problems, you'll have something like, I'm looking at number 3 right now, 4x plus 3y equals negative 12. AX, that's like the 4 is the A, plus by, the 3 is the b, equals c. These capital letters just get replaced with whatever numbers are in that equation. This is just the form or the layout of it. And we'll write over to the side that this is called standard form. And then we have another form equation that's written where instead of having x and y on the same side of the equation, we have y by itself. Y equals, and then we'll write mx plus b. Some of you might find this familiar. If not, no worries. We're going over it now. So standard form was the ax plus by equals c. This second equation form, does anybody know what that's called? It's okay if you don't.
Slope intercept form.
Yes, slope intercept form. Slope dash intercept. So these are the two forms that we will see equations in when we're dealing with systems for now. So once we've got those written down, we're going to talk a little more about it. I am going to outline this so I know that this is more just like a key. It's a guide to help us remember the different forms that we might see. Now, the words standard and slope intercept might not mean a whole lot to you right now. That's okay. They'll mean a little more as we get more into this. For now, just have those words written down and know that this is what we are referring to. If there is a y by itself at the beginning, you know you're in slope intercept form. If your x and y are on the same side before the equal sign, you know you're in standard form. That's the main difference. Okay. So underneath that, we're going to start talking about that word I've said a few times. I'm going to write in all caps, substitution. Sub, S-T-I-T, substitution. T-I-O-N. Substitution. Whenever we are using this method to solve a system of equations, usually you're going to have two equations where one is in standard form and one is in slope intercept. And you'll notice all the problems we've done so far today are following these forms where we have x and y on the same side for one equation and then y by itself on another equation. So when we are using substitution, let me pull out the problems that we just did. Let's see. When we're doing substitution, for example, number 1 on the do now, when we're plugging in numbers and values, when we're replacing, thank you, those numbers, that's a fancy way of saying we're substituting. Substituting is the same thing as plugging in. I like to think of it like a substitute teacher. If I'm not here and there is a substitute, it's like another person is coming in my place to replace me for that day. Just like when I plug in a number, we are substituting. We're replacing that number and that variable for that problem. Substitution is just a fancy word to say replacing and plugging in numbers and variables. So I'm going to write that below.
So like the Y,
Uh-huh.
replacing the 3 in place of the Y,
Yes.
substitution.
Yes, exactly. Substitution happens when we replace. So I'm going to write replacing slash plugging in number values and variables. To solve systems. So beneath that, we are going to write an example of a problem, and I'm going to take that from this worksheet that all of you should have. If any of you do not have this worksheet, maybe I missed somebody, I do have copies on the wooden table up at the front of the room. And I think, let's see, let's use number 4 to start. So I'm going to write over here the problem from number 4, which is y equals x minus 4 and negative 2x plus 4y equals negative 12. And I'm going to write over to the side that this is number 4 from the substitution worksheet. So looking at these two equations in the system, my first equation says y equals x minus 4. Is this in standard form or slope-intercept form? The first equation. Slope-intercept. How can I tell that this is slope-intercept?
There's a Y and X on different sides.
Yeah, x and y are on different sides, and my equation starts with y equals. Slope-intercept starts with y equals. Then we have something with an x, mx. That would be like 1x plus b. You're adding negative 4 here, minus 4. So that is a slope-intercept equation. My second equation is negative 2x plus 4y equals negative 12. Is that standard or slope-intercept?
Standard.
Standard. We have x plus y equals something. Ax plus by equals c. So this is in standard form. X and y are on the same side. So whenever we have an equation in slope-intercept form, this is a lot like the challenge problem we just did. I've got y by itself. So I can start substituting things. I'm going to look at my second equation and see I have two variables. I cannot solve an equation when there's two different variables. What can I do to make my second equation have only x's in it? Can I do that?
Yeah.
How?
Negative 2x plus 4, and then in parentheses, x minus 4.
Yes. So what we're going to do is I'm going to notice, okay, I've got y equals, well, it's equal to x minus 4. My second equation has y next to a 4 right here. If I want to have only x's, let's substitute x minus 4 for y. And I will make little notes as we do this. So I'm going to write here, number 1, substitute. Or plug in. To replace y with x minus 4. So here's where I'm going to rewrite that standard form equation, but instead of y, we're going to write x minus 4, so that now we will have all x's, no y's. So I'm going to do that right now. Negative 2x plus 4. Instead of y, we're writing x minus 4. Equals, don't forget the rest of the equation, equals negative 12. So I've done that, I've plugged it in. What do I do next? Yes, distribute or multiply. Every time you plug something in, what you're going to do right after that is usually distributing or multiplying. So we're going to multiply 4 times x and 4 times minus 4. So I'm going to write here, step 2, multiply / distribute. Now, if these side notes, where I'm writing 1 and 2, if those are things that you know are going to help you when you look back at your notes later, write them down. If you're somebody that gets more confused when you have lots of words mixed in with your math problems, then don't write it. Your notes should be something that you know you're going to find useful later on. Write what's going to help you. So we're multiplying or distributing here. And when I multiply 4 times x, what do I get? 4x. And now that 4 times minus 4 or negative 4, what do we get? Good, negative 16. So I've done that, and I'm going to cross this out so I don't accidentally bring it down. So I've done my multiplication, I've done my distribution. Where do I go from here?
Bring the negative 2x down.
Yes, bring the negative 2x down. That is still part of our problem. Negative 2x.
And 12.
And the 12. I don't want to forget there's a plus right here. I'm adding that to 4x equal all that. So here's my equal, and then I'm bringing down the other side, negative 12. Be very careful not to lose any of your negative signs, because that will certainly change your answer. Here, sorry guys. Here we go. Okay, so I've done all of that. At this point, I'm going to draw a line through my equal sign to help me stay organized. What should I do now?
Bring the x's together.
Bring the x's together. After we've multiplied and distributed, we have an equation we can solve, but we want to get our x's together. We want to combine like terms. So that is going to be step 3. Combine like terms if there are any. And I have a negative 2x plus 4x. What will I get when I combine those? 2x. Good. So when I put those together, I get positive 2x. And we will bring everything else down. I still have minus 16 equals. Still have that negative 12 on the other side. Now I've got 2x minus 16 equals negative 12. Where do I go from here? Add 12.
16.
Yes. So why is it a better idea to add 16 instead of adding 12?
It follows in suit with the way you're looking at the equations.
Yeah, that's a good way to say it. We're looking to see how can I get this x by itself. If I have 2x minus 16 equals negative 12, adding 12 to both sides is just going to bring more over here with my x. That's going to get me further from having x by itself. I'm trying to get things away from the x. So what needs to go away? Minus 16. So we need to add 16 to both sides. And that will cancel and get rid of minus 16.
2x equals 4.
Perfect. 2x comes down, equals comes down, and then negative 12 plus 16 is positive 4. So I'm going to say this whole next part is step 4. Get x by itself. Solve. That's what we're doing. We're solving for x now. Okay, and then we've just got one last step from here. What do I do? Yes, divide by 2 on both sides. And our final answer for x is x equals 2. 4 divided by 2. That's 2. Good job. Okay, so in 4 steps, we have solved for x. Are we done with the problem? No, we still need to find y. We still need to find y. So, yes. Just like in the first step, we substituted the value that we had for y. We plugged it in. Now we're going to substitute the value for x, which is 2. So I can plug that into the first equation. Y equals x minus 4. We'll do y equals 2 minus 4. So let me bring this equation down. Let's see, how do I want to organize this? I'm going to use this. Step 5. Now we're going to substitute again. Plug in. To replace x with 2, or with the number that we just solved. Okay, so I'm going to bring down that top equation right here for step 5. That was y equals x minus 4. And we just found x is 2. So instead of x, I'll rewrite it again. Y equals 2 minus 4. And what will we get when we do 2 minus 4?
-2.
-2. Okay, so x is +2, y is -2. And there's one final step here for step 6. We have both of our values. What's the very last thing we do?
Right now.
Yes, we want to write x and y as a coordinate. Right? X, y as a coordinate. So my coordinate, what number comes first?
2.
2, and then my -2 for y. And that's it. We have done it. We have done it. Okay, so here is a nice little guide that you can always refer back to when we're using substitution. We're always going to be doing it this way by following these 6 steps. So I'll leave this up for a minute for anybody that is still copying it down. And before we go on, please ask questions if you're confused about any part of it. Does anybody still need to see this page? Or can I move on? Turn it. Please tell me if you need to still see it. I'm happy to go back. So I'm just going to title a new page, and now we're going to actually go to that worksheet that I gave you a moment ago. Just going to title this first. Algebra 2, Unit 1. Day 2 notes continue. Two for me. And what I'm going to title this page as is substitution practice problems. That way, if you look back at your notes, you know that's what I'm doing on this page. And before I have you do some practice on your own, I would like to run through just one more together to really solidify it. And I am thinking we'll do, let's look at number 6 on this worksheet together. Because number 6 has got a number on the X, and we haven't done one like that yet. Okay, so I'm just going to write here number 6 from worksheet. Okay, and number 6, the two equations are 2x plus 4y equals 8, and y equals 3x minus 12. I've got my two equations for my system. What form is my top equation in? Is this standard or slope intercept? That's standard form. Good. Standard form. We have ax plus by equals 8. 2x plus 4y equals 8 for C. My second equation, y equals 3x minus 12. What form is this one in? Slope intercept. I've got y equals, so it's slope intercept. So I know I've got one that's already got a y by itself, so that should give you a hint as to what's going to be substituted first. Does anybody think they've got a good idea of what our first step here might be? Yes.
Plug this.
Plug them in. What am I plugging in?
I put, the 3x negative 12 with the y.
Yes, this y here next to the 4. Perfect. I know that this is y. Y is equal to 3x minus 12. So I can replace y or substitute into that top equation. Instead of y, we'll put 3x minus 12. Let's do that. I'm going to rewrite the whole problem. 2x plus 4 instead of y. We have 3x minus 12 equals 8. Perfect first step. We have substituted our y. Make sure everybody can see that. So step 1 is done. What is step 2?
Multiply 4 and 3x.
Good. We're going to multiply 4 and 3x and the 4 and the minus 12. We're going to distribute. Good. That gives us 12x minus 48. And I'm going to cross this out so I don't bring it down. And go ahead and finish what you were saying.
Equals 8, and I need to bring down the 2x plus.
Perfect. We're going to bring everything down now. 2x plus the 12x minus 48 equals 8. Okay. Now at this step, when we start combining things and we start solving and getting x by itself, drawing that line can be very helpful to keep your work organized. So I'm going to do that. What should I do now? I got 2 like terms. What
12 minus 48.
is,
12x.
so I have 12x.
Or no, you do, you bring the 2 and 12.
Yes. Okay. Be careful with your combining like terms. You have 2x. You have 12x. You have minus 48. There's no x. I can't combine 48 with anything over here. I got to look at my x's. Those go together. So I'm going to circle or underline those, do something to show we're putting them together. Join them. What is 2x plus 12x? 14x. Good. 14x, I'll cross them off. Minus 48. Bring everything down. Equals 8. Diane, did you have your hand up? Oh, okay, just making sure. Okay, so now I have 14x minus 48 equals 8. What now? Yes, add 48 to both sides.
Equals 56.
And perfect. So those canceled. And we'll bring everything down again. 14x equals, you said 56? Okay. Now what?
Divide by 14.
Divide by 14. Get that x by itself. Beautiful. 14's cancel. Bring down the x, it's by itself, equals 56 divided by 14. You said that's 4? Yes, it is 4. Okay, x equals 4. That is wonderful. Wonderful, wonderful. Okay, so we've solved for x. We're like 3/4 of the way done. We're almost there. What should I do next?
Plug in your X into the Y.
Yes, now we're going to substitute x, the 4, into our slope-intercept equation. Y equals 3x minus 12. I know what x is now, so let's replace it. I'm going to rewrite this as y equals 3 instead of x, 4. So 4. Okay. And now that I've done that, where do I go?
You distribute the influence.
Yes, every time you plug something in, if there was a number in front, you're distributing, you're multiplying. So 3 times 4 gives us 12. Bring everything down. Y equals 12 minus 12. Y equals 0. Good. Okay, we solved for x, we solved for y. Last step. Coordinate. What number comes first? X, which is 4. Y is 0. 4, 0 is your answer. Wonderful. There we go. Okay, guys. So we just did number 6 together from the worksheet. We did, I believe it was number 4 together right before this. What I would love for y'all to do at this point, once you're done copying this down, is I'm going to set a little timer for about 15 minutes. During that timer, I want you to go through this substitution worksheet that I gave you, and I want you to try to solve as many of these on your own as you can. While you're working on these, you can help each other. Sometimes helping a friend or getting help from a friend is one of the best ways to learn, because especially once you feel good about it and you can help someone else, you know you've mastered it when you can teach it to someone. I am also here as a resource. Ask me for help. We will go over as many of these as we need to after that 15 minutes is up. And of course, I can take questions while the timer is going. But I'm going to pause our recording, set that timer, and your task is to finish as many as you can in that time. Okay, so you guys have had about 15 minutes there to practice some of these on your own at your tables. Like I said, I want to open the floor now to allow you all, tell me, were there any problems that you had problems with? Anything that we want to go over as a class? Any tricky ones? Yes.
First one.
The very first one. Okay, let's look at it. Number 1. I'm going to write that down on here. So number 1, we have y equals 0. And we also have negative 2x plus 4y equals 2. Okay. So tell me, what were you thinking for your first step here?
I plugged in a 0 for Y.
Perfect. That's exactly what you should do. We plug in the 0 for y. So y equals 0. There's a y in my standard form equation. So we're going to replace or substitute y with 0. I'm going to rewrite that problem. Negative 2x plus 4. Instead of y, we're going to write 0 equals 2. So this problem looks a little different from what we've been doing, but it'll actually come out to be a shorter problem since we already know y. Sometimes we second guess ourselves whenever a problem is actually a little easier because you think it can't possibly be that simple. Sometimes it is. So now that I have my y plugged in, I have 0 instead of y. What would I do at the next step here?
Distribute.
Distribute. Any number times 0 is what? 0. 4 times 0 is 0. When we get 0, I could bring down plus 0, but do we normally do that when we're solving an equation? When we cancel something out, it's because it is 0. We could just cross this out because 4 times 0 is 0. If that feels uncomfortable, though, what I'm going to do is I will bring down plus 0, and I'll show that we won't need that. So 4 times 0 is 0. I'll bring everything else down. Minus 2x plus 0 equals 2. This is where, if this was a number other than 0, we would subtract that from both sides, right? If I take minus 0 on both sides, does that change any of my numbers? No. Subtracting 0 wouldn't really do anything. It would just be extra stuff to write. This is why I would just cross it out. You don't need it. Yes. You added 2, this 2?
Yeah.
Okay.
I did the positive 2 on that side and the positive 2 on the other side.
Okay, so we added 2. Is that what we should do here?
No.
Why can't I add 2 here?
Because it's in there.
Not just because it's a negative. What's happening? I have negative 2x. Yes, there's an x. Remember, when I have a number in front of a variable, this is really a multiplication thing happening here. I have negative 2 times x.
So just down the negative 2x equals 2 and then divide by.
Yes, if I want to get rid of negative 2 here, I need a divide because this is negative 2 times x. So we need to divide by negative 2. Does that make sense why we're dividing? Okay, we're going to divide because it's not a separate number out on its own. If a number is attached to a variable, if I tried to add 2x to both sides, I can't combine that. I got to divide to get it off of my x. So that cancels my negative 2's. And I'll bring down my x equals, what's 2 divided by negative 2? Negative 1. That's what we'll get. That makes sense? Okay. Wonderful. So I have x equals negative 1. What do I do now?
Find, write your variable there.
Yeah. Okay, so here's the thing.
Right on your coordinates, your
Right. Kind of a trick question. We're actually done. We just need to write our coordinate because normally in the last few problems, we would have y equals something with an x in it. And we'd have to plug the x in to find y, but we already know y is equal to 0. So I don't have to do any more plugging in. I already know it. So we can go ahead and write our coordinate. What's my x? Negative 1, and my y is 0. So our answer for number 1 is negative 1, 0. Did that clear up number 1 for you? Does that make sense? Okay, perfect. Perfect. Do we have any questions about number 1? Are there any other problems we might like to see worked out? Number 2?
I got decimal.
For decimal? Okay, did anybody else get like a weird answer for number 2? If not, that's fine. Let's run through number 2. Let's look at it.
We should do, yeah, one on this stuff.
Okay, I'm gonna write number 2 here. Number 2, we had, oh, this one can be tricky. Negative x. This throws people off sometimes, and that's okay. Negative x minus 2y equals 7. And y equals 4x minus 8. Okay. I've got my problem all written out. What should I do first?
Why?
Yes, let's plug in the value for y, substitute it into that first equation. I see y is by itself here, and y is equal to 4x minus 8. So we're going to put that in the y of the other equation. So I'm going to bring everything over. Negative x, let's see, minus 2 instead of y, 4x minus 8. Equals 7. Okay. I plugged in, or I substituted my y. What do I do now? Distribute. Now be very careful when you distribute. I'm sure this is where some of you might have made your mistake. This is not just 2 times 4 and 2 times negative 8. It's a minus 2, so it's negative 2 times positive 4x. What is that? Negative 8x. And now I have negative 2 times negative 8. Positive 16. So there's a plus 16. We have to be so careful with our signs. I know that's something that is a little tricky to get the hang of, but the more practice you do, the easier it gets. So I'm going to cross that out so I don't accidentally bring anything down that I don't need to. And what comes down now?
Negative x equals, and then equals 5 and 7.
Yes, negative x comes down. Still have the minus 8x plus 16 equals 7. Now, I bet this part may have been a little tricky for some of you too. Negative x and minus 8x. Oh, yes, yes. If there's no number, you know it's like having an invisible 1. So this, if it helps, you can write a 1 in front of that x. It's negative 1x minus 8x. Negative 1 minus 8 is negative 9. So negative 9x. Bring everything down. Plus 16 equals 7. I forgot to draw my line. Okay. Now what do I do?
Minus 16.
Minus 16 on both sides. I have negative 9x coming down. Equals, you said that's negative 9, perfect. Yes. Then our final step, we divide by that negative 9. Get x by itself. And I'll bring down my x. Bring down equal. You see what you did? Good.
Man, I erased all of this.
Are you getting what we're doing here now, though?
I had it, and I erased it. And then I put it 8.
Ah,
I erased
Well.
everything, and I erased the x and the 1. I put the 1 in. I erased it.
they can be tricky. They can be tricky. The key is slow. Don't rush. Double check you're writing the right numbers. Pay attention to your signs. Math is a process. We want to be very exact with everything we're writing, making sure that we're putting things in the correct place. So we got x equals 1. How can I use that to find y? Plug it in. Okay. I'm going to write my other equation, my slope-intercept, y equals 4 instead of x, 1. So I'm substituting, plugging things in again. Y equals 4 times 1 minus 8. What is 4 times 1? It's 4. Okay, bring down -8. Bring down y equals. Last step, y equals -4. Good. X is 1, y is -4. Let's make a coordinate. What number comes first? 1. -4 is next. That is our answer. Okay. Okay. All right, you guys. So there's another one together. What we're going to do now, because I'm looking at the time, it is 11:40. We have 15 minutes until lunch. I'm going to go ahead and give you guys your exit ticket, give you time to finish it here in class. If you want to see any other problems worked out or you need any help, have questions, please feel free to come up to me and ask. I am here to help and only here to help. That's literally my job. Yes.
Well, I don't have your next period, so can I bring this home?
Yes, absolutely. Absolutely. Okay. No, those are for you to keep. They're just more practice if you need it. Or if you just want to do a little extra practice. I'm gonna move this page. If anyone needs to see it, I'll go back to it. Now for exit tickets, I will typically always make them right in front of you, and then I will run to the copy machine and make copies. You can write it yourself on a piece of paper if you want, but know that in about 5 minutes I'll have copies if you want yours to look exactly like this. So I'm going to write name here. And as always, this exit ticket is not technically due until Friday, October 10th. That is this Friday at noon, 12 p.m. So for your exit ticket today, I would like, let's see, I'm going to take one right from this worksheet. Let's do solve. Solve the system by substitution. And it's just one problem today. 3x plus 3y equals 0 and y equals x plus 6. This is your system. This is your problem. Please write your answer as a coordinate to get all your points. So I'm going to write a little reminder up here, x comma y. That's how your answer needs to be written. I'm going to freeze my screen so that you all can still see this. And then I'm going to go run copies for everybody in this room. However, if you, I guess, finish by the time I get back, you don't have to rewrite it. But if you are writing this on your own, please title it as a day 2 exit ticket so that I can keep track of what day it is in the grade book. But once you finish that, you are free to go. That is all for today, and I'll be right back with those copies.